Welcome to The Explainer. Today, we're going to go on a kind of detective story, a journey beyond what we can see, to try and uncover the hidden rules of reality itself.
All right, so to kick things off, let's start with something we can see. A galaxy that is, well, just truly spectacular and incredibly strange.
So this thing is called Hoag's Object. It was discovered way back in 1950, and for a long time we weren't even sure it was a galaxy. The best guess for how it formed is a kind of cosmic smash-up. A smaller galaxy basically punched a hole right through a bigger one billions of years ago. The only problem? There's absolutely no trace of that other galaxy. It's like a perfect cosmic crime scene.
And that right there is our first big clue. The beautiful, complicated, and sometimes just plain weird universe we can see, it's really just the surface. It's being shaped and governed by fundamental forces and substances that we can't see at all.
So, let's investigate the biggest unseen rule of them all: gravity. For centuries, it was this invisible force that ran the whole show, but nobody really knew what it was. So, what is it?
Well, for a long time, we tried to explain gravity with things we could actually picture in our heads. Take Lesage's theory. He imagined these tiny particles flying around, constantly pushing on everything. So if you had two objects, they'd shield each other from some of the particles, creating a push from the outside that feels like a pull on the inside. It's a really clever idea. But then, in 1915, Albert Einstein came along and revealed a reality that was just so much stranger. He said gravity isn't a push or a pull, it's a bend. Mass literally warps the fabric of space-time, and we're all just rolling along those curves.
And just think about the sheer timescale here for a second. In 1915, Einstein predicts that these huge cosmic events, like two black holes smashing into each other, would send literal ripples through space-time, gravitational waves. It then took a full 100 years of us building better and better technology before the LIGO experiment was finally sensitive enough to actually detect one of those ripples, proving his incredible idea from a century before.
Okay, so we've got a new rule book for gravity, and it's a beautiful one. But what about the actual stuff that's doing all the bending and warping? I mean, what is the universe really made of?
And here is where our detective story takes a really, really wild turn. See, when astronomers added up all the gravity they could measure in the universe, it didn't match the amount of stuff they could see. It wasn't even close. It turns out that everything we have ever seen, every star, every planet, you, me, is less than 5% of what's actually out there. Just 5%. The other 95% is made of two total mysteries: dark matter, which is the stuff providing all that extra gravity holding galaxies together, and dark energy, an even stranger force that's actually pushing the whole universe apart, making it expand faster and faster.
But the weirdness doesn't stop with the 95% we can't see. Oh no. If we zoom all the way in on our tiny little 5% slice of what we call ordinary matter, things somehow get even stranger. And in fact, this is where we find one of the biggest arguments in the entire history of physics.
You see, this was Einstein's huge problem with quantum mechanics. He pointed out this weird thing where if you entangle two particles, they stay connected no matter how far apart they get. You could have one on Earth and one on Mars. If you measure the one here, you instantly know the state of the one on Mars, faster than light could have ever traveled between them. Einstein hated this. He called it spooky action at a distance, and was convinced it meant the theory wasn't finished. There had to be something deeper, something we just weren't seeing yet.
So, Einstein spent the rest of his life searching for a unified theory, a single set of rules that could connect the world of the very large, gravity, with the world of the very small, quantum mechanics. And his search for this single underlying reality, well, it finds this really surprising echo not in a physics lab, but in the writings of a philosopher from the 17th century.
This philosopher, Baruch Spinoza, he proposed a really radical idea for his time. He argued that the universe and all of its laws are themselves the divine, not some creator sitting outside of reality pulling the strings, but the single interconnected substance that is reality. And this idea, this vision of a unified whole where everything is just a different part of the same underlying thing, it resonates so powerfully with that scientific dream of finding one elegant theory to explain it all.
So our little cosmic detective story has taken us all over the place, from the edges of the universe to the heart of an atom, and from the frontiers of physics right into the depths of philosophy. Think of it like we've been peeling back the layers of a cosmic onion. We started with the visible universe, only to find out it's just a tiny 5% fraction of the whole thing. We looked at gravity and realized it's actually the shape of reality itself. We zoomed into matter, and we found it's all connected by these spooky links, and that it even echoes these ancient philosophical ideas of unity.
Every layer we peel back is stranger and more interconnected than the last.
So the big takeaway here is this. Our understanding of the universe is really just beginning. Every single answer we find only seems to uncover deeper, more profound questions. The detective story is far from over, which leaves all of us to wonder about that final, thrilling question.